Hello there, I am Jandarvik Villarin, and today we're gonna discuss ether. We're gonna focus on naming ether by their common name and by using the IUPAC system. But first, let's have our objectives. At the end of this lesson, the student should be able to identify the general structure of ether, use the IUPAC nomenclature system in naming ether. 3. Draw structures of ether using their symmetrical and asymmetrical names. So in organic chemistry, ethers are a class of organic compounds that contains an oxygen between two alkyl groups. They have the formula ROR, with Rs being the alkyl or aryl or vinyl group. This example here is that we draw are an ether. As what we have read, ethers are oxygens that are attached or bond to R groups. These R groups are alkyl, aryl, and vinyl groups. So when we are going to identify ethers, we simply look for an oxygens that are attached to two R groups, or alkyl, aryl, or vinyl group. So I'm just gonna draw a arrow there. The ether group is a common structural features of many natural compounds, like this example here. So as you can see, the ethers placements in these examples, oxygens are connected to two R groups or alkyl, aryl, or vinyl group. And now we're gonna draw and try naming ethers. Ethers are named by their common name and the IUPAC system. The common nomenclature or naming of ethers follows the rule of naming different alkyl or aryl groups attached to the ether. So here are the names of carbons. Carbons are named depend on how many carbons that are there in each group. So if there is one carbon, we're gonna call it methane. So here there are two carbons in this group, so we're gonna name it ethyl. And in this group there is one carbon, so we're gonna name it methyl. So now that we know the name of each carbon, we're gonna name and write the ether in an alphabetical order. Since E is first before M, so we're gonna put first ethyl, then methyl. And lastly, in naming the common name of ethers, we're gonna put ether at the end of the naming. This example is an example of unsymmetrical naming of ethers. Unsymmetrical because the two R groups are not the same. Counting the number of carbons in each groups and name them and put ether at the end. Here are the few branches of substituents. So just remember this one because this is very important. And now I'm gonna draw another example. So pay attention to this group here. So as you can see, it's the same to the picture that I have shown. This one is much larger than this one. So, so obviously, this is an example of unsymmetrical ether. Now we count the carbons of this group. Since this group has 4 carbons, we're gonna name this butyl. Butyl, or this group here, have 3 branches. So we're gonna name or put first third here. So this group here will be named as third butyl. Third because it has 3 branches on the substituent. So here we have methyl because it only has 1 carbon. So this compound or structure are named 3-butyl methyl ether and unsymmetrical ether. So remember this picture here so that when you encounter this kind of structures, you can easily identify and determine the prefixes and names. Again, when naming ethers and their common names, just count the carbons in each group and write them in an alphabetical orders. And after that, don't forget to write ethers at the end. Sec and third prefixes are not determined or used in determining in an alphabetical order. Let's have another example. This example here is an example of symmetrical ether. Means that both our groups are identical or the same. So how do we name this kind of ether? Since each group have the same carbon, they have 3 carbons, so we're gonna name this propyl. Each group have 2 branches, so we're gonna name it iso. So we're gonna write iso here. So it will be named isopropyl. This example is an example of symmetrical ether. Means that both groups are identical. So instead of naming it isopropyl ether, we're gonna name it diisopropyl ether. Di means there are 2 isopropyl ether. So now, let's name ether by the IUPAC system. In the IUPAC system, ethers are named by choosing the bigger group as our parent name, and the other group or substituent that are attached to the oxygen is named oxy. Example, methoxy or ethoxy. So in naming ethers in the IUPAC system, we choose the longest carbon chain as our parent name, and the other group that are attached to the oxygen are what we call the alloxy substituent. Now, let's try naming ether in the IUPAC system. So I'm just gonna draw here an example of unsymmetrical ether. We're gonna count or number the carbons in a way that it will give the lowest number to the oxygen. So as you can see here, this group here will be our parent chain because it has the longest carbon chain. And on the other side, we're gonna start naming it. So we're gonna name this group here 1-ethoxy. Eth because there are 2 carbons, which is ethane, and our suffix is changed into oxy because ethane is attached or connected to the oxygen, and there's 1 there. We tend to number it, that tends or gives the substituent the lowest number. No? So in this group, our parent chain, since it has 5 carbons, we're gonna name it pentane. So this ether is 1-ethoxy pentane. Again, when naming an ether in the IUPAC system, we choose the longest carbon chain as our parent, and the substituent will be changed into alkoxy. So instead of naming it ethane, we're gonna name it ethoxy because ethane attach or bond to oxygen. So now, let's have another example. This example is a little bit complex because it has a chiral and several substituents, but let's try and name it. So instead of naming our parent as pentane, we're gonna add cyclo to our parent name. If the parent name is a chiral shape, then we will add cyclo. So we will name it cyclopentane. So the name of this compound is 1,1-dichloro 3-ethoxy cyclopentane. So the explanation of that is that, as you can see there, here we have our two carbons that are attached to oxygen. So we name it ethoxy, and since our parent is a chiral or ring shape, we don't just name it pentane. Let's add cyclo. So we're gonna name it cyclopentane. So in numbering or counting again, we're gonna number it in a way that the substituents will get the lowest number. So our substituents there have the 2 chloro or chlorine. So we're gonna name it 1,1 for each chloro, then dash dichloro because there are 2 branches of chloro in our substituents, then dash 3 because, as you can see, the numbering there, oxygen or our substituent have a 3 number there, so we put 3, then dash ethoxy cyclopentane. And that's the end of our discussion. I hope you learned something, and I hope that this video helped you in understanding the naming of ethers by their common names and by using the IUPAC system. So these are the summary of our discussion. The name of the compound is written out with the substituents in alphabetical order, followed with the base name derived from the number of carbons in the parent chain. Commas are used between numbers and dashes are used between letters and numbers. There are no spaces in the name. That's all. Thank you and good day.